So I'm going to show you problem 10.41, the calculations and how, depending on which order you do the subtraction of your pre and post data, how you can actually get the exact same conclusion. Now, you still are responsible for all four steps of the inference toolbox: population parameter, conditions, calculations, and interpretation. However, I'm going to just skip to the calculations to once again show you that the order doesn't matter of your list, you can still achieve the same conclusions. Alright, so I'm going to basically split the screen. Remember, we had our pre-data in list 1. We had our post-data in list 2. And now I'm going to show you how, if I do pre minus post, how I can get a certain set of calculations. And then I'm also going to show you, if I were to have done post minus pre, how I can get the same conclusion. Now, if I do one var stat of list 3, it's going to give me a certain set of numerical summaries. So I'm going to get an x bar of negative 1.45. I'm going to get a standard deviation of 3.203. And I'm going to get a degrees of freedom of 19 because my n was equal to 20. Now, similarly, if I do one var stat of list 4, I'm going to get an x bar of 1.45. Standard deviation is going to be the same. It should make sense that regardless of the order I subtract, it's still spread out the same amount. Degrees of freedom is still 19 because my n is still 20. Alright, so now I'm going to do two separate calculations. I'm going to have my sample mean difference of negative 1.45 plus or minus, using my degrees of freedom, and I wanted to do a 90% interval here. So 90% interval. I'm going to get a critical value of 1.729 times my standard deviation over square root of 20. Now I would do the same thing with this other data, except it would be a positive 1.45 plus or minus 1.729 times, once again, the standard deviation over square root of 20. So what you're going to notice is when you do this, you're going to get the same interval, except it's going to be opposite signs. So there you go. Now you'll see, if we look on this left-hand side, pre minus post, if that's giving me negative numbers, what that means is that my pre-score had to be small and my post-score had to be big. I had to take away a larger number from a smaller number to put me into the negatives. Now similarly, if I look on this right-hand side, if I get a positive number back when I do post minus pre, post needed to be big and pre needed to be small. So notice, either way I look at these intervals, they're both showing that with the post-test scores, had to be higher than the pre-test scores. So once again, it didn't matter if I did list 1 minus list 2 or list 2 minus list 1, you'll see that you come to the same conclusion. The post-test scores were, in fact, do appear to be higher than the pre-test scores.